Hello everyone. In this question, it is given that if the equation cos to the power 4x minus sin to the power 4x plus cos 2x plus a square plus a equal to 0 has at least one real solution, then we have to find the solution set of A. Okay, so the equation is cos to the power 4x minus sin to the power 4x plus cos 2x plus a square plus a equal to 0. Okay, and this has at least one real solution. Okay, so these first two terms we can factorize it, right? We can write it as cos square x whole square minus sin square x whole square plus cos 2x plus a square plus a equal to 0. Okay, now these first two terms can be factorized as a minus b into a plus b, right? So this becomes cos square x minus sin square x times cos square x plus sin square x plus cos 2x plus a square plus a equal to 0. Now this first term becomes equal to cos 2x, right? And this is equal to 1. So cos 2x times 1 is again cos 2x. So this becomes cos 2x. And we have another cos 2x here. So this becomes 2 cos 2x plus a square plus a equal to 0, right? So if I keep the a in left hand side, this becomes a square plus a is equal to minus 2 cos 2x, right? Now we know that the value of cos theta ranges between plus 1 and minus 1. So the value of 2 cos 2x, right? The value of 2 cos 2x, this will range from minus 2 to plus 2, right? So here it is minus 2 cos 2x. So if I multiply this whole equation with minus 1, only the sign will change and the inequality will change, right? So this will become 2 greater than equal to minus 2 cos 2x, and this will be greater than equal to minus 2. So these and these are exactly same. Only this minus 2 has become plus 2. The sign has changed. In theory, nothing has changed between these two equations. Okay. So this is identical to, if I just change the side, this will again become minus 2 will be less than equal to minus 2 cos 2x, and this will be less than equal to 2, right? So this is the range of this RHS of this equation. Okay. So this implies that minus 2 will be less than equal to a square plus a from this equation, right? A square plus a, and this will be less than equal to 2. That is, a square plus a is in the interval minus 2 to plus 2. Okay, so I can get two cases from here, right? So case 1 will be that a square plus a is greater than equal to minus 2. That is this first half. Okay, and the other case will be that a square plus a is less than equal to plus 2. So from this first case, we get, if I take this 2 to the other side, this will become a square plus a plus 2 is greater than equal to 0. So this is a quadratic expression, right? So if I try to find the discriminant here, the discriminant is b square is coefficient of a, which is 1 square minus 4 times 1 is coefficient of a square times 2, right? So this is 1 minus 8. So this is less than 0, right? So there are no real roots in this expression, in this quadratic expression. Okay, so this means that this curve of this expression, the curve of this expression, if this is the x-axis, the curve is going to be always above the x-axis, right? If I say this is the x-axis, the curve will always lie above the x-axis. Since the discriminant is 0, so there is no real root, right? So this means this is always going to be a positive. The expression, this is going to be always positive. Okay, since it is lying above the x-axis. Okay, so this means that a square plus a plus 2 greater than equal to 0 is true for all a which is real. Okay, since there are no real roots, the expression, quadratic expression, will never intersect the x-axis, so it will always be positive. It will always lie above the x-axis. So this is always true for any r, for any a belongs to real numbers. Okay, So I will look for the other case to find any particular solution of A on A if it is available or not. Okay, so if I take this to the other side, this will become a square plus a minus 2 less than equal to 0. So if I factorize it, the product is minus 2 and the sum is 1. So I can write it as 2a minus a, right? So this will become a plus 2 times a minus 1 less than equal to 0. So this first term can be written again as a minus of minus 2 times a minus 1, and this is less than equal to 0. So here this will imply that a, since the product is negative, a has to lie between minus 2 and plus 1, and since this is a slack inequality, both are in the closed interval. Okay, a can take either minus 2 or 1 since it is equal to 0. It is not a strict inequality. Okay, so from this case, the second case, we find that a can take any values from minus 2 to 1. So the final solution set is this. Solution set of given equation is a lies in the interval, closed interval, minus 2 to 1. Okay, so this is the final answer. Okay, a lies in the interval a lies in the closed interval minus 2 to 1, and this is the final answer. Okay, so this is it. Okay, I just factorize this equation in terms of cos x and sin x, and from there I just evaluated the range of this expression minus 2 cos 2x. Okay, and then I substituted the values of a, and from there I uh, partitioned it into two cases, and for one case it is always trivially true, because for any a which is real, this expression, this first case, is always going to be positive, so we are not getting any solution set. And from the other case we see that in this particular interval this is satisfied, so this is the required solution set of a. Okay, so this is it. Thank you.